For 2 days, nobody in Sarangani could explain what they were looking at. The ocean was gone, not receded a few meters like a low tide. Gone. 200 meters of open seabed sat exposed under the sun. Coral reef and seagrass that had never once touched open air, now baking in the heat, covered in fish that had no way to get back to the water. Local fishermen who had worked these waters their entire lives stood on ground that 1 week earlier would have been 10 feet over their heads. This wasn't erosion, it wasn't a freak tide, it was something the Earth itself had done in a matter of seconds. And once you understand what actually happened beneath these beaches, you'll understand why scientists are calling this one of the most dramatic coastal transformations recorded in the Philippines in decades. To understand what happened here, you have to understand where here actually is. Mindanao is the second largest island in the Philippines, home to roughly 26 million people, and its southern coast sits almost directly on top of one of the most active fault systems in the Pacific. 50 kilometers offshore lies the Cotabato Trench, a subduction zone where one section of the Earth's crust is being forced beneath another, inch by inch, year after year, building up stress the way a coiled spring builds tension. For most of 2026, that stress had been quietly announcing itself. In January, a swarm of thousands of small earthquakes rattled the region, mostly too minor to notice, but enough that seismologists were watching closely. Communities along Sarangani and Davao Occidental went about their lives, unaware that beneath their coastline, something was building toward a release. The region had seen strong earthquakes before. A magnitude 6.8 event struck in November 2023, damaging enough that older residents still remembered exactly where they were standing when it hit. But the historical record along this stretch of coast goes back much further than living memory. Records compiled by Philippine seismologists document at least 7 significant earthquakes here between 1917 and 2023, ranging from magnitude 5.7 up to a staggering magnitude 8.0. The Cotabato Trench, in other words, wasn't an unknown hazard. It was a known, repeating source of major seismic events, and by early 2026, it had been building toward its next one for years. Nothing, however, had prepared this coastline for what was coming on the morning of June 8th. At 7:37 in the morning, on the very first day, students across Mindanao were returning to school after summer break. The ground gave way. A magnitude 7.8 earthquake tore through the Cotabato Trench, its epicenter just 32 kilometers offshore from the town of Masim, at a depth of roughly 33 kilometers. The shaking was severe enough to be felt as far away as Malaysia's Sabah state, across the water, and tremors registered in cities throughout Indonesia's Sulawesi Island. Buildings collapsed in General Santos City. A landslide buried homes in the mountains of Sarangani, killing over a dozen villagers in a single instant. Within minutes, tsunami warnings went out along the southern Philippine coastline, and waves over a meter high began rolling into Kiamba and Mayasim, with smaller surges detected as far away as Palau and southern Japan. General Santos International Airport was forced to suspend operations entirely. By the time the immediate danger passed, more than 60 people were confirmed dead, hundreds injured, tens of thousands displaced, and over 3.2 million students had their classes suspended indefinitely, while officials inspected more than 6,200 schools for structural damage. But the earthquake's most extraordinary consequence hadn't even been discovered yet. 2 days after the quake, residents near Barangay Balangonan started noticing something impossible. Sections of the shoreline that had always been underwater were now dry land. At first, some worried the sea itself was disappearing, a fear rooted in old warnings that a retreating ocean can signal an incoming tsunami. But this was different. This wasn't the water pulling back temporarily, ready to come roaring back. The land itself had risen, and it wasn't going back down. Philippine seismologists dispatched quick response teams to investigate, and what they documented reshaped how the world understood this earthquake. Along stretches of Sarangani and Davao Occidental, the seabed had been lifted by nearly 2 meters. Permanently. The shoreline had physically pushed outward by as much as 200 meters. Coral reefs, seagrass beds, and marine habitats that had existed underwater for generations were now sitting exposed in the open air, and they were dying in real time. Government scientists released images showing wide bands of bleached, sun-scorched coral littered with the bodies of fish, eels, and shellfish that had no time to escape before the water pulled away from them forever. Satellite imagery from the European Space Agency's Copernicus program later confirmed the scale of it in stark detail. Before and after images taken less than 2 weeks apart, showing an entirely reshaped coastline where there had only ever been open water. Stop for a second and let that sink in. If this uplift had happened gradually, over centuries, it would be a footnote in a geology textbook, the kind of slow tectonic creep that reshapes coastlines so imperceptibly that no single generation ever notices. Instead, it happened in the span of a single earthquake, in the time it takes to read this sentence aloud, and the ecological cost is only beginning to be measured. Residents initially feared the exposed sea life might poison the air as it decayed in the heat. Environmental officials confirmed the fear wasn't misplaced. As reef organisms broke down under the tropical sun, the smell alone became a health concern for nearby communities, on top of everything else they were already dealing with. So what actually causes solid ground to lift itself 2 meters out of the ocean in a matter of seconds? The answer lies directly beneath the Cotabato Trench, where one tectonic plate is being forced underneath a second. For decades, friction locks these two plates together at their boundary, and the upper plate gets dragged downward along with the one sinking beneath it, storing enormous elastic energy in the rock the entire time, like a diving board being pushed down and held in place by an invisible hand. When that lock finally breaks, the upper plate doesn't just shake and settle, it springs back, releasing all of that stored energy at once. Coastlines directly above the rupture zone can rise, or in other cases sink, almost instantly, as the crust rebounds into a new equilibrium position. Geologists call this phenomenon cozy-ismic uplift, and it's the same basic mechanism behind some of history's most famous earthquake aftermaths, from the 1964 Alaska earthquake to the 2010 Chile earthquake, both of which permanently reshaped hundreds of kilometers of coastline in a matter of minutes. Picture pressing your thumb down hard into a stress ball and holding it there for years, then suddenly letting go. The surface doesn't ease back to where it started. It snaps upward, past its original resting point, releasing every bit of tension in one violent motion. That's what happened along 50 kilometers of Philippine coastline on the morning of June 8th, and Philippine volcanologists have confirmed the phenomenon is directly and unambiguously tied to movement along the trench itself, not some separate or unrelated process. For the communities living along this stretch of coast, the consequences go far beyond a strange new beach to photograph. Coastal uplift permanently alters the navigation channels that small fishing boats have relied on for generations, sometimes leaving once reliable harbors too shallow or too reshaped to use safely. Shallow water fisheries that sustained entire barangays may take years to recover, if they recover at all. And for families where fishing isn't a hobby, but the entire household income, that's not an inconvenience, it's an existential threat to their way of life. One provincial official described teams being sent out with no way to even estimate how large the affected area truly was, because the transformation was simply too extensive to survey quickly, and there's a harder truth underlying all of it. This uplift is not a sign that the danger has passed. Seismologists have been explicit that a release of stress in one section of a fault does not mean the surrounding trench is now safe. It can just as easily mean neighboring segments are now carrying added pressure, primed and waiting for their own release. More than 138 aftershocks followed the initial quake, ranging up to magnitude 6.7. And on June 26th, nearly 3 weeks after the first rupture, another strong earthquake, magnitude 6.5, struck the same offshore region near Sarangani, rattling a population that hadn't even finished counting its losses from the first one. For the 26 million people living across Mindanao, that's not a closed chapter. That's a trench that has proven twice in 1 month that it isn't finished moving. To put that scale in perspective, That's roughly the entire population of Australia living along a coastline that has now demonstrated it can rise 2 meters without warning in the middle of an ordinary Monday morning. It's the equivalent of every single person in New York City, Los Angeles, Chicago, and Houston combined, standing on ground that can shift beneath their feet without a moment's notice. Philippine authorities have been careful to say the uplift itself poses no direct further danger. It isn't a precursor to a tsunami, and the ground beneath these communities isn't going anywhere else, for now. But scientists monitoring the Cotabato Trench are watching closely for what comes next. Continued aftershock activity, the possibility of stress transferring to adjacent fault segments that haven't yet ruptured, and the long-term ecological fallout as exposed reefs and seagrass beds either find a way to recover or die off for good. The Philippines sits at the center of the Pacific Ring of Fire, and trenches like this one don't rupture once and go quiet. They rupture, redistribute stress to their neighbors, and wait. Whether the next release comes in weeks, months, or years is something no seismologist on Earth can answer with certainty. What we do know is that a coastline just proved, in the space of a single morning, exactly how much power had been building beneath it for decades. Subscribe to stay ahead of what's coming.